Introduction. In ancient times, the Romans used stones for counting and basic arithmetic. Calculus is the Latin word for stone. Today, we know calculus is used to solve complex problems that regular mathematics cannot complete. Some examples are found in economics, astronomy, the military, air traffic control, radar, engineering, and medicine, just to name a few. The foundation for the general ideas of calculus comes from ancient times, but calculus itself was invented during the 17th century. The first principles were presented by Sir Isaac Newton of England and the German mathematician Gottfried Wilhelm Leibniz. Newton and Leibniz deserve equal credit for independently coming up with calculus. Each accused the other of plagiarizing their calculus concepts. When combined, however, their separate works established our first understandings of this subject. Newton was also able to establish our first insight into physics, which would remain uncontested until the year 1900. His first works are still in use today. The linked video below is an entertaining historical cartoon about the invention of calculus. It's roughly 8 minutes in length, but it does present a lot of great information. So if we click on the link, it opens up the video for us. Here's the URL for it, and we can watch it at our own time. There are three main concepts in the study of calculus: limits, derivatives, and integrals. Everything else will concern the ideas, rules, and examples associated with these three principal concepts. For example, after you're done learning about derivatives, you're going to be applying those concepts to solve real-world problems or analyze functions. Those are just some examples. Differential calculus discusses the rate of change and slope of curves, and integral calculus deals with the accumulation of quantities and the areas formed below curves. Calculus was developed out of a need to understand continuously changing quantities. Newton, for example, was trying to understand the effect of gravity, which causes falling objects to constantly accelerate. In other words, the speed of an object increases constantly as it falls. So how can someone determine the speed of a falling object at a specific instant in time, such as its speed as it strikes the ground? No mathematicians prior to Newton and Leibniz time could answer such a question. It appeared to require the impossible, dividing 0 by 0. Differential calculus is concerned with the continuous or varying change of a function and the different applications associated with that function. These concepts offer us a better understanding of the behaviors of mathematical functions. It allows us to optimize functions. Thus, we can find their maximum or minimum values and determine other valuable quantities that can describe the function. The real-world applications are endless. You can talk about maximizing profit or minimizing cost, maximizing efficiency, finding the point of diminishing returns, determining the velocity or acceleration of an object, and the list goes on and on. The other branch of calculus is integral calculus. Integration is the reverse of differentiation. It allows us to add an infinite amount of infinitely small numbers, and therefore we can find the area or volume of any planar geometric shape. Applications of integration are also extensive. Integrals can be used to find the area between two curves, find the distance of an object, its velocity and acceleration. It can also be used to find volume. It can also be used to solve work problems, how to find the center of mass or kinetic energy, and it deals with probability, to name a few. The preceding information means that all ideas of calculus originated with the following two geometric problems in mind. First one is the tangent line problem. When given a function f and a point p, whose coordinates are x initial, y initial on its graph, find an equation of the line that is tangent to the graph at this point P. The second geometric problem is known as the area problem. When given a function f, find the area between the graph of f and the x-axis on an interval, a closed interval, from a to b, where a and b are numbers. But before we discuss the tangent line problem, we first need to talk about limits. Why, you may ask? Well, the tangent line problem is actually solved using limits. So let's start talking about them.